Hello everybody. So today I want to talk about calculus. The topic that is about the limit comparisons test. So now I want to show you how to answer. We know that n squared equals to n squared. Now because they start at n equals to number 1, so that means this one you got the positive, this one we keep the same. So when we add more this one, we have like this. So because we add more value in here, that's why this one is bigger than this one. Now if we put into the ratio, that should be about 1 over n squared plus 2n plus number 3 is smaller than 1 over n squared. Now we put the square root for the both sides. And now we need to consider about this one. So we can use about the integral test. That is about the integration from number 1 to positive infinity. And we have the square root of s plus number 5 over s squared. So we can use about the limit. So that should be about 8 approach to positive infinity. This one we change for 8. Now we can use about integration by trigonometric substitution. So I will put s equals to the square root. We can put about number 5 tan t squared. Because if I put this one gone here, we have number 5 tan t squared, number 5 and number 5. We can do about factorization. Tan t squared plus 1 we change for secant of t squared, and later that we simplify the square root. The s we have number 2 tan t secant of t squared. So we need to change the bounds of number 1 and 8. When s equals to number 1, so we put number 1 gone here, and we divide both sides by number 5, and you got about t equals to octane of 1 over the square root of number 5. Because we put the square root for the both sides, that's why we have the square root of number 5. So when s equals to 8, so t equals to octane of the square root of 8 over number 5. So number 1, that is about this one. 8, that is about this one. S we change for this one and this one. The s we change for this one So this one we have tan t squared plus 1. And this one that is about secant of t squared. The square root of secant of t squared, we have secant of t. This one we have 25 tan t to the power of 4. This one we have number 10 tan t secant of t squared. And now we need to simplify the numbers. So number 10 over 25. So we have number 2 and number 5 in here. Tan t we simplify. Secant of t and secant of t squared, we have secant of t to the power of 3. Now I will put the number go outside. Next, secant of t, that is about 1 over cosine t. This one, that is about sin t over cosine t. And now we simplify. This one that is about cosecant of t to the power of 3. Now I will focus about this integration. So I will put cosecant of t and cosecant of t squared. So we can use about integration by parts. So I will put about u equals to cosecant of t. Later that we need to do first the derivative for the both sides, and we have like this. dv that is about this one. The integration of this one, that is about v equal to negative cosine t. So we have u multiplied by v minus we have the u multiplied by v. Negative and negative they cancel. So we just have cosecant of t, cosine t, and cosine t. So we have the integration cosecant of t, cosine t squared dt. So cosine t squared, that is about cosecant of t squared minus number 1. And now we need to expand this one. And we know that this one equals to this one. So I will put this one go to the right. So this one we have number 2. Later that we divide both sides by number 2. So the integration of this one, we have Ln of the absolute value of cosecant of t plus cosine t, and I will put about c. Now we need to return back to this one. The integration of this one, that is about this one. And we put the bounds from this one to this one. Now we put the bounds going here and here. Next, so when x approaches to positive infinity, so this one will go to positive infinity. Octane of positive infinity, we have b over 2. Similar for this one. And this one. And this one. So we calculate this one and we have 3.14 because we just calculate the exact value. So this is about conversion. So we can conclude that this series in here, this is about convergent. Because this is about convergent, that means this one should be about convergent. This is the end. Thank you for watching.